Welcome to part 2 of lesson 15. We are starting here on page 140. So now we are working on the application of z-scores and standard deviation. And in number 9, you will see that a particular brand of tires lasts an average of, the mean is 40,000 miles with a standard deviation of 3,000. What is the probability a tire selected at random lasts more than 42,000 miles? Alright, so knowing we want to find probability, we need to first find a z-score. So, remember that z is your data minus the mean all over your standard deviation. So when I put numbers into that, my data, I want to know about 42,000 miles. And I know the mean is 40,000 and the standard deviation is 3,000. So when I subtract the numerator, you get 2,000 divided by 3,000, I end up with approximately 0.67. So 0.67, right, is a little bit more than half. It's about right there. And the key is more than 42,000. More than means to the right. So I want to find the area to the right of this line. Now, when I go back in your packet to page 138, right, we're looking up our z-score of 0.67. Well, you will notice that we don't have 0.67, but we do have 0.65. So we will use an approximation for our z-score of 0.65. Now when you do that, you see that it tells you 0.65, the area to the left is 0.7422. And this is why I like these pictures. You can actually draw on them. You get so you can see exactly what you're dealing with. Well, the area to the left is 0.7422. I don't want the area to the left. I want the area to the right. So I would then take 1 minus 0.7422 to get my answer of 0.2578. So the probability that a tire selected lasts more than 42,000 miles is 0.2578. All right, I would like you to try 10 and 11. Same basic type of problems, draw a picture and that kind of thing, and then come back and check them out. So hit pause, try 10 and 11. Alright, here in number 10, again we are given the mean, the standard deviation, and it says 200 milligrams per deciliter is the current cutoff for hypercholesterolemia, which is whatever that is. So there's our data value. So we know our z-score is data minus the mean over the standard deviation. So my z-score, when I do that math, comes out to be 0.38. Again, that is not on my table, so I would look at a z-score of 0.4. 0.38 is right here. So the area to the left of that, so this is where my z-score of 0.4 is. The area to the left, according to the chart, is 0.6554. Now, the question is, we want to know the proportion of 20 to 34-year-olds who have hypercholesterolemia. Whew. Well, this is the cutoff. If you have less than that, you do not have it. So once again, we are looking for the area to the right, because the area to the right is where the person has whatever it is. So 1 minus 0.6554 gives us our answer of 0.3446. So, you know, roughly 34% of 18 or 20 to 34-year-olds have hypercholesterolemia, blah, 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 blah. Number 11, the average IQ score is 100 points with a standard deviation of 15. What is the probability of selecting someone at random with a score under 120? Okay, so again, z-score, 120 is the data minus the mean of 100 over the standard deviation of 15. And when you do that, it comes out to be 1.33. Looking at our table, we have 1.3 and we have 1.4, so I will, round nearest and I get 1.3. So here's 1.3-ish. Now, we want to know under 120. So under is to the left. So this one, we want to find the area to the left. Yay! Right? Makes it a little bit easier. So when I look 1.3 up in the table, I end up with an answer of 0.9032. So the probability of selecting someone at random with a score under 120 is 0.9032. So to interpret your answer, so the 0.9032, if we change that to a percent, 90.32% of people have an average IQ score under 120 points. Now we can use this as a percent because this this part here that I'm coloring in green, this is part, right? But it's part to the whole. And if you remember from a couple sections ago, part to whole means we can use percentages. Now that leads us right into page 141 because page 141 is all about percentiles. So all of these probabilities that we're finding are part to whole, and because they're all part to whole, we can deal with all of them as percentiles. So we've kind of already answered number 12, and that refers back to question number 11, what percentile of IQ scores is an individual who scores 120 points. Well, we found, you'll remember, 0.9032. So if we change that to a percent, 2 places, we would get 90.32%, or you could say the 90th percentile. Generally, with percentiles, we round to the nearest percent. I'm not mad at you, but in Blackboard, just make sure you're paying attention to the directions of what to round to. In number 13, to be a member of Mensa, I actually have the Mensa puzzle calendar right next to me here. I think it's kind of funny. The high IQ society of the world, one must score at least 135. So to find part A, what percentile is an IQ score of 135? So we first must do, we got to find our Z-score. So data minus the mean. If you remember from the previous page, the mean is 100 and the standard deviation is 15. So that gives me an approximate Z-score of 2.33. I'm going to go ahead and round that to 2.3. So when I round this to 2.3, I'm going to draw this in green here on the table. So here's 2.3. When I change that, or I look it up on the table, I end up with 0.9893. If I round that to the nearest percent, right, 2 places over, 99th percentile, it would be an IQ score of 135. So actually, I think I just answered the question. Oh, no, I didn't. My bad. I'm sorry. I should read more carefully. Part A is what percentile? So that's the 99th percentile. Now, part B, what percent of the population actually qualify? Well, if you qualify, you're the little bitty bit over here on the right, right? Because you got to have 135 or higher. So we would take 1 minus 0.9893, and we would end up with 0.0107. Change that to a percent. 1.07% of the population would qualify for a Mensa, the Mensa Society. I bet I couldn't keep up with those conversations. Anyway, number 14. Number 14, we're going to go from a different way. Okay, and I'm actually going to pause this for a second. All right, so we're talking about Uncle Bob here in number 14. Uncle Bob says he is taller than 80% of all men. All right. So he is saying that his percentile is 80 percentile. Well, let's change that to a decimal. That would give me 0.8. So Bob is telling me that that would be his probability, right? This is the probability. So we need to use, from that, we need to find the Z-score. So we're working backwards. So now we know that his probability is 0.8. So I want to draw your attention. This is your chart that's on page 138, right? If you look down here, right here, this is where the probability is right around 0.8. So that's what Uncle Bob says he is. He says his probability, right, his percentile is 80th percentile. So since that's 0.8, that would mean his Z-score is 0.85. So we know that Uncle Bob's Z-score is 0.85. So did you see how I did that? 80th percentile. Percentile is the probability, so I found the 0.80, and that let me find my Z-score of 0.85. Okay, so now that I have a Z-score, think about what Z-scores mean, right? Or Z-score, we have the data minus the mean over the standard deviation. Have you forgotten that? I hope not, because you're going to need it. So now, I'm going to go to a new page with this data. If we think about it, we've got the Z-score, 0.85. We don't know the data, right? That's the unknown. We don't know how tall Uncle Bob is. But if you go back to page 139, we know that the average height of men is 70 inches and the standard deviation is 5, right? So that's from page 139. And now we can solve this. So in solving this, right, we want to get rid of the fraction on the right-hand side first. So I will multiply both sides by 5. Because when you multiply on this side, the 5's will cancel out. I'm left with x minus 70. And 5 times 0.85 gives me 4.25. Then I want to add 70 to both sides, right, equal sign. And that means Uncle Bob would be approximately 74.25 inches tall when you do the math with that one. Let's go back here now to page number 15. I want you guys to try 15. So 15, where we have the average 1-year-old male baby weighs, the weights, the mean is 22.7, standard deviation is 2.7. What percentile is a 1-year-old male baby who weighs 19 pounds? So go ahead and hit pause and go ahead and work on number 15. All right, so knowing that he weighs 17, this baby weighs 19 pounds, so 19 minus 22.7, all over the standard deviation 2.7, you end up with a z-square of negative 1.37. Well, we don't have that in the table on page 138, so we'll round that to negative 1.4. When you look up negative 1.4, it gives you the probability of 0.0808. We want to know, they say what's the percentile? 2 places to the right, and we are at, I would say, the 8th percentile. I mean, you could say 8.08. We could also round to the nearest whole number. All right, last part of this we're going to do is page 142. So I would like you right now to try to answer the questions 1 through 5 on page 142, and then come back and check your answers. All right, so looking at men less than 5 feet tall. So I think of everything in terms of pictures. So 5 feet, first of all, is 60 inches. So 60 minus 70 over 5 gives me a z-score of negative 2. That's over here. So if we went less, we want to the left, and we would get 0.0228. So as a percent, 2.28% of men are less than 5 feet tall. Similar for women. Still 60 inches, so 60 minus the average for women divided by the standard deviation, and we're going to get a z-score of negative 1.4. So when you look at, right, so now we're here of the z-score of negative 1.4, we still want to the left. It gives us 0.0808 as a percent, or at 8.08% of women are less than 5 feet tall. 2A, what percent of men are more than 6 feet tall? So now looking at this picture, okay, so 6 feet is 72 inches. So 72 minus 70 over 5, 2/5 is 0.4. So here's my z-score. So this is a horrible normal curve. I'm kind of upset with myself right now. So, all right, so we know that 0.4 is to the right of the mean. And we want to know more than 6 feet. So we're looking for this area over here. Well, when you look at your table, a 0.4 gives you 0.6554, because that's area to the left. Now, to get that area on the right, we're going to take 1 minus 0.6554, and we will get our answer of 0.3446. And then as a percent, 2 places to the right, 34.46% of men are more than 6 feet tall. Let's do that same question for women. So now looking at women, I still have 72 inches. So 72 minus the average of 65 divided by the standard deviation of 3.5, we get a z-score of 2. So more is over here. When you look up 2 on the table, it gives you 0.9772. Again, we want to find the area to the right, so we're going to subtract that from 1, and we get 0.0228. Change that to a percent, and 2.28% of women are taller than 6 feet. And none of them are friends with me, because I deal with short people. Number 3, who is taller relative to their own gender? So now we're going to kind of compare these two. So I'm going to do the woman over here. So the woman, 5 feet is 60 inches plus the 7 inches that she has. So the woman is 67 inches. Subtract her mean and divide her by the standard deviation. She will have a z-score of 0.57. So she's 0.57 standard deviations above the mean. We'll do the man. 6 foot is 72 inches. So 72 minus 70 divided by his standard deviation, he has a z-score of 0.4. So he's only 0.4 standard deviations above the mean. Therefore, the woman is taller relative to her gender because she is more standard deviations above the mean than the man. All right. Number 4 is similar to that. Who is shorter? A 5 foot tall woman. Okay, so let's do the woman here. This is 60 inches. So 60 minus 65 divided by 3.5. She has a z-score of negative 1.4. And then if we look at our friend, the 5'6" man, well, remember 5 feet is 60 inches plus the 60 that's left over. So 66 minus the average of 70 divided by 5, and that man will have a z-score of negative 0.8. So now who is shorter? Well, again, the answer is the woman because she is more standard deviations below the mean than the man, and therefore she is shorter. Number 5, if you want to check out where you fall on that whole list, go for it, but I'm not dealing with it, and we are also skipping page 143. So that wraps up section 15.